do with you first is we're going to sketch this sine graph on paper. So go ahead, well, you can get out your sine graph if you want to, or I'm going to show you mine as well. But we're going to translate this to just sketching it on some paper. Okay, so what I want you to notice are these important points. Where does the graph cross the x-axis? Those are also called the zeros of the graph. Where are the maximum points and where are the minimum points? And if you know those, then you can connect the dots. Okay, so looking at the graph of sine, where does it cross the x-axis? Crosses at negative 2 pi, negative 1 pi, 0, 1 pi, 2 pi, 3 pi. So it's crossing the x-axis at all the pi's. Okay, let's go to our paper. I'm going to make this have zeros, otherwise known as x-intercepts, at all the increments of pi. Okay, so I graphed the zeros. Next, I want to graph the maxes. Okay, so I'm going to go back over here. Where do the maximum points occur? Remember, that's where it reaches 1. At negative 3 pi over 2. At pi over 2. At 5 pi over 2. Okay, well, I don't have all of those on my graph, but I do have negative 3 pi over 2. Max is 1. Do we want to do a scale of 1/2 or 1? What do you think? 1/2? Okay. Then let's mark it. So a max here. Okay. Halfway between the next two zeros. Halfway between the next two zeros, I'll be at a minimum. So the next one will go down to negative 1. Okay. Halfway between the next two zeros, I'm at a maximum. And then halfway between the next two zeros, I'm at a minimum. Do you see how I'm alternating that? So then, once I know the zeros, the maxes, and the mins, then we can pretty easily just connect them. Remember, don't make them little sharp TPs and Vs. Try to make them smooth. Not always easy to do, but that would be two full waves of a sine curve using these important points. Where are the zeros? Where is it crossing the x-axis? Where are the maxes? Where is it reaching 1? Where are the mins? Where is it reaching negative 1? Okay? All right, so what we're going to do next is we're going to take a graphing calculator. This is called our parent function. This is the plain old vanilla, nothing fancy done to it. And we're going to change the equation. You can see some different ways we're going to change them down here. Are they evacuating? And then we're going to make notes about how that changes the graph compared to that parent function. Okay? Just like we've done with other things in math. Okay, get your graphing calculator out. All right, I want you to go to mode. Notice that my x-axis is in radians. So remember how I showed you once before you could change the mode? This thing, get going here. Okay, so mode is right next to the second key. And look at the third or fourth line down, depends on which calculator you're on, and make sure that radian is highlighted. Okay, now I'm going to set this graph up on my calculator just like this one is. So what I mean by that is I'm going to go to Window, right next to Y equals, and I don't want my x-axis to go from negative 10 to 10. That's not what this is labeled. This is labeled negative 2 pi to 2 pi. So negative 2 pi. Pi is above the little arrow key like that you would use for power. Right over here under the clear. So you have to do second pi. Now when I push enter, it's going to remove the pi symbol and put a decimal there. I don't like that, but I can't change it. Okay, then my x max, far right on the x-axis, I want 2 pi. What is my x scale on here? How much is each of these? 45. Okay, but in radians, that's what? Pi over 4. Pi over 4. So my x scale, so that it matches my paper, is going to be pi divided by 4. Now again, when I push enter, it's going to change it to a decimal. Okay, is everybody good with this? Okay, now my y-axis, let's see what this is. 1, 2, 3, 4, 5. Well, let's do like maybe -6 and +6. And if I really want it to match what I have on my paper, my scale is 0.5. Everybody good? Okay, so now we're ready to type in the equation. So go to y equals, and let's just do sine x first. Sine x. And graph. And we should get a nice sine curve that matches what I have on the paper. Good? Okay, so the first change I'm going to make to this equation is I'm going to graph 4 sine x. Y equals, insert a 4 there. Okay, let's see what it does to the graph. Oh, okay, how would you describe that change? That's a vertical stretch, yes. It made it taller, didn't it? Okay, what is my new maximum value on this? And if you're counting, remember we went by halves. Anybody? 4. It's going up to 4. What is the new minimum? -4. You know, I'm going to change my scale to 1 so I can read that better. I'm going to go to Window, Y Scale, and make it 1 so I don't have to count by halves. Window, Y Scale 1 is the only change I made. Now I can see that that's 4 a little bit better. Okay, so my new max is 4, and my new min is -4. Okay, so this change that we just saw is called the amplitude. The amplitude, I would say, is 4. So the amplitude is the distance. Here's the middle of the graph, and it's going to come like this. The amplitude is this distance here. I'm going to use an A for amplitude. Okay, so it's not the distance from the highest to the lowest, it's from the middle to the highest or from the middle to the lowest. Yes? The X? Right next to the green alpha key. Because on here, each one of those lines is 45, which is the same as okay, any questions on that? So amplitude is just how much more I've stretched it vertically, basically. Okay, so let's look at this next one. -1/2 sine x. If you want a fraction key, remember how to find that. It's alpha y equals -1/2 sine x. Okay, let's see how it changes it compared to the parent graph. Okay, what happened? Yeah, it's like someone sat on it. It squished it vertically. Very technical term there. Squished vertically, or we call that a vertical compression. But there's another change. Can I see it? Actually, it did not, and this is how I know. So to the right of the origin, I have one full wave. I still just have one full wave. even though it's flat. But look what happens in a normal sine curve. When I pass through the origin, I'm on my way uphill. But what happened here? Yeah, over the x-axis. So that negative in front, which, I mean, we've talked, you know, with parabolas, that's what happens, right? You put a negative in front and it flips it upside down. So it does the same thing for a sine curve. So it reflects it over the x-axis. That's because of the negative. And then it's a vertical compression. It's flatter. But what's my amplitude? Like, from midline to the highest point, how far is that? What, Max? 0.5. Like, I mean, you can visually see how flat it is. I changed my scale to 1, so that first tick mark is 1. It's not reaching 1. So the amplitude is 1/2. Now, I want you to notice this. Even though there was a negative 1/2 out front, I still just say the amplitude is 1/2. So amplitude, I take the absolute value of that lead coefficient. Okay, let's graph this next one. Y equals sine 2x. Okay, so this is not a 2 out in front. This is a 2 with the x. So let's see what happens here. Okay, how would you describe, remember this is our original graph on the paper. What happened? There's more waves. How many more waves? Twice as many, double the amount. Do you see where the double would come from? The 2x, yeah. Okay, so let's describe this. Using technical terms, what would I call this? A horizontal stretch would be like this. Compression, yeah. I've squeezed in more curves in the same span. So horizontal compression. How many times as many waves? 2 times as many. Okay, so remember I said yesterday that the period of a sine curve was 2 pi. Now, if you haven't watched the video yet, that won't make any sense to you, but once you watch it, hopefully it will. And what that meant was, if I start walking on the curve from any point, once I have gone 2 pi, I will start to repeat the same exact curve again. So this little chunk of curve just keeps repeating. Okay, but what is the period on this graph? How far am I going? Remember, this is 2 pi out here. How far do I go on that graph before the curve repeats? Hello? I've got a curve here, and it comes down, and it goes back. And I have finished one curve from there to there. How far is that if this whole window's 2 pi over here? 1 pi. So that means that a full curve occurs every pi radians as opposed to every 2 pi radians like the plain old sine curve. Okay, so the period has changed and now it is pi instead of 2 pi. So it was cut in half, whereas I had 2 times as many waves. But doesn't that make sense? If I'm squeezing in twice as many, then that means in half that distance I'm completing one. That's a little confusing, isn't it? Okay. Next, let's change it up by just putting a +4 at the end. Be sure to close off that x so your calculator doesn't think the +4 is part of the sine. What happens to a function if we tack on plus something? Oh, what happened? It definitely shifted. It like picked the whole curve up and moved it up 4 units. Now, did it stretch it taller or shorter? It did not. No, it just literally picked it up and moved everything forward. So the center line, remember the line that it's oscillating on, is no longer the x-axis. The center line is right through there. So where is that center line now? At y equals 4. Okay, so vertical shift up 4. The center line or midline, we use those two words interchangeably, is at y equals 4. It's no longer on the x-axis. Okay, what's my maximum value now? What is this top y value? Linear? 5. And what's the lowest y value? 3. Okay, so my max goes up to 5 now, and the min goes down to 3. But that makes sense if we're centering it around 4. That means I'm going one above for the max and one below for the min. What's the amplitude? Still 1. Remember, amplitude is distance from center line to the highest or center line down to the lowest. So the amplitude is still just 1. Okay, one more change. Go to sine. Now we're going to change what's in the parentheses. Alpha y equals, we'll get your fraction key, pi over 2. Okay, let's see what happens. Does it look like our normal sine curve? I mean, in general, yes, but does it look exactly like this? No. How does it differ? Moves, yeah, left or right. Now, actually, I could justify it saying it went either way, couldn't I? I could say, okay, this point that was at the origin is now here. Or I could also say, oh no, it's back here. But if I look at the equation, remember the equation was minus pi over 2. You okay? Do you remember when we did the rational functions and we put something like this 1 over x minus 2? What did that do to the graph? Right 2. It's the same change. It's where the x is, and I'm adding or subtracting something to it, and it has the opposite effect, just like this one went right 2. This one is going right pi over 2. Guess what would happen if I made that a plus? It would go left. I mean, these are the same rules that we used with the rational functions. No different. Okay, so I have a little summary / kind of a cheat sheet for you. Dissecting sinusoids. You didn't know you were going to do a dissection today, did you? I'd be grossed out if we were actually doing a dissection. Y'all still dissect things in science? Like dead animals?
We just have dissected a frog.
Okay, yeah, that's what we had to do, is to a frog.
What is this?
Graphic organizer.
Where'd you find that? I said, no Brady thing. On the sideline here.
All right. Look at this big, huge equation in the middle. That represents all the changes that we just made to that plain old vanilla equation. We put a number in front. We put a number in front of x or theta. I'm using theta here. I think I had x on the paper because in the calculator you have to use x. We added or subtracted a number here, and we added or subtracted a number at the end. So we did all of these things, not all at the same time, but separately just a second ago. All right, so let's go back and look. When I changed the number in front of sine, for example, the 4 and the 1/2 here, what did it change? What did the 4 do, and what did the 1/2 do? Look over here at our notes. The amplitude. It changed how tall or short the graph was, which inadvertently also changes the maximum and minimum values. Okay, so this thing here, and my pen I wanted to use, okay, here we go. This thing here is called the A, is called the amplitude. It's nice because it actually starts with A. The amplitude is the absolute value of A. Okay, so when we had that negative number out front, we didn't use a negative amplitude. We just call the amplitude whatever the number is. What is the effect as A gets larger? So compare having that A of 4. It was a stretch compared to 1/2 that we called compression. So what if I made A 8, 10, 20? What would happen? It would get taller, wouldn't it? To use a non-technical term, it's a vertical stretch. The graph, I'm going to say taller. Okay, graph gets taller. Okay, what happened when it was negative, with the negative 1/2? It reflects over the x-axis. Okay. Now, guys, these things are no different from when we did the rational functions. Like, these are all the same changes we've looked at before, and these changes hold true with any function, set of functions. Okay, so let's talk about this number in front, this thing that I have labeled K. What does it change about the graph? Let's see where we changed it on here. Okay, we put a 2 in front. It was a horizontal compression, and it made us have 2 times as many waves. Okay, so that number in front changes the what? The distance of the wavelength, right? Which technical term for that is the period of the function. But I'm also going to say how about the frequency of the waves? Okay, what is the effect as it gets larger? Okay, so 2 was bigger than 1, and we had 2 times as many waves. So it smushed more waves into the same space. Okay, so that was it was making the period smaller. And we were seeing more waves appear. In technical term, it's a horizontal compression. Okay, so as it gets smaller, then the opposite will happen. The period is larger. Fewer waves appear. And it's technically a horizontal stretch. All right, so this thing here, this is the one that trips everybody up. If it's a minus, it will go to what happened in ours back here? When we had a minus, it went right. If it's a plus, it's going to go left. So there's a technical name that we use for that. It's really a horizontal shift. But the technical term for that is phase shift. And I don't know why we have to have a special word for that, but that's what that means. If it's a plus something, it shifts left. And if it's a minus, it shifts right. Okay, this thing that we tacked on to the end, like the +4 right here, it moved everything up 4, and it's just straight up called a vertical shift. No technical term for that. If it's a positive, so if it's a plus number, it shifts up. And if it's a negative, it shifts right. I'm sorry, down. Okay, so these things at the bottom here are little formulas that we will use. This number k will determine the period of the function, and we're going to use the 2 pi over k instead of the 360 over k, so I'm going to make that out there equal to the period. And then here's a formula for phase shift that we will use. C divided by k. Okay, and here is our lovely equation. Okay. All right, so let's use this on some things. Let's go back to our notes now. Okay, so keep this sheet handy. Okay, for each equation, we're going to determine the amplitude, the period, the phase shift, and vertical shift. Okay? All right, amplitude. Amplitude comes from the number out in front, and we take the absolute value. So if there is a 1/2 in front, what is the amplitude? 1/2. Okay, the period. Let's go back to my sheet here. The period is determined by 2 pi divided by k. K is in front of theta, or it could be an x, whatever's representing the angle. What number's in front of x? 1. So the period is 2 pi over 1, which is just 2 pi. So the period has not been changed here. You know what? I'm going to do this little note here. This is my A. I should have done this. And then there is a 1 in front there. That is the K. Okay, phase shift. When do I have a phase shift? Let's go back and look at this. I have a phase shift if I have something added or subtracted to the angle. I don't have anything, do I? So is it moving left or right? No. I'm just going to say none. Or you can say NA, not applicable. A vertical shift. I have a vertical shift if there's a number added or subtracted at the very end of the function. I don't have a number added or subtracted out there, so there's no vertical shift. Is this graph reflected? Is this thing flipped over the x-axis? No. What would have to be there in order for it to be reflected? A negative in front of that. So no. Okay, let's go to the next one. What's the amplitude? Here's the A value, but what's the amplitude? 3. I'm going to take the absolute value of -3. So amplitude is 3. But the fact that that is negative, what do I know is going to happen? It's going to be reflected. So let's just drop down there and go ahead and say yes. Will be reflected over the x-axis. Okay, the period. Go back to your sheet. The period is determined by this number in front of theta, or x. Do I have a number in front of there? I do. It's 3. We determine the period by taking 2 pi and dividing by that number. So this number is k, and the period is 2 pi over k, which is 2 pi over 3. And if I could reduce it, I would, but that's it. So that means every 2 pi over 3, a full wave will occur before I get a whole nother wave. Okay, phase shift. That's that horizontal shift. It only occurs if I have something added or subtracted inside the parentheses. Nothing. No phase shift. Vertical shift occurs only if I have something added or subtracted at the end or outside by itself. None there. Do y'all have a question? Okay, keep going then. What's up with this -5 out front? Is that a coefficient in front of cosine? I would rewrite this one, y'all. I would make this negative cosine. I'm going to come back to that x over 2 in just a second. -5. Does that make sense if I rewrite it that way? Okay. I don't have to write it that way. I like it that way because that lets me see, oh, that -5 is actually going to be a what? Vertical shift. Yeah, this number out here by itself, that's your up and down shift. So that -5, by moving it to the end, it just helps me to see that there will be a down 5 vertical shift. So this is the H value. Okay, what number's in front? What's my lead coefficient there? -1. So what's the amplitude? 1. Absolute value of -1 is 1. But because it's negative, I know what will happen. Reflected. Okay, phase shift. I don't have anything added or subtracted inside these parentheses, so there is none here. But the period's a little tricky on this one. What's the coefficient of x? 0.5. Where did I get 0.5? I don't see a 0.5. Yeah, there's a 1 in front, but then it's over 2. So if I have x over 2, that's the same as 1/2 x. So it's kind of a condensed way of writing 1/2 x. So guess what? What do we call that? K value is 1/2. K is 1/2. Okay, I have to use K to find the period. So period is 2 pi over K. I could have given myself a little more room on that one. Okay, 2 pi divided by 1/2. 2 pi over 1 divided by 1/2 is what? What, Luke? You're saying it? 4 pi. Okay. Now, the bad thing about typing that in on your graphing calculator is it's going to give you a decimal. So if I were going to type something like this in a calculator, I would grab that little one because it'll keep pi in your answer. All right, next one. What about that 4 sticking out front by itself? It's a loner. What's that going to be? What kind of shift? Vertical shift. So if you want to rewrite it and put it at the tail end, you can. But that is going to be my vertical shift. So in terms of my formula, that's my H. This number is what? In terms of all this stuff. A. Right there in front of theta is the K. So K is just 1. And then this plus pi, I have a C on this one. So this is C. Okay, so let's put it all together. Amplitude. 2. How will I find the period? Remember, period is 2 pi divided by k. 2 pi divided by 1 is just 2 pi. Phase shift. Okay, we have one here. Phase shift, if you have something added or subtracted inside the parentheses, if it is positive, it's going left. If it's negative, it's going right. So this is shifting left pi divided by k. C over k. But my k was 1. So I'm going to put C over k is pi over 1. So it's just pi, and I'm going to say left. Or left pi, pi left, either way. Okay, do I have a vertical shift here? Yeah, that positive 4 is going to shift everything up 4. Is it reflected? How would I know? That lead coefficient would need to be negative, so this is not reflected. Yes. Alrighty. Alright, just a few more here. Alright, find the phase shift in period. Okay, first thing I'm going to do is write down my little formulas here from my little sheet. So I'm going to write down period equals 2 pi over k. Phase shift, I'm going to use just PS for that, equals C over k. So we'll treat those as formulas. Where do I find k? In front of the angle. And where do I find C? Inside the parentheses. Okay, so here we go. Period is 2 pi over, what is my k here? What number's in front of theta? 1, someone said it? 1/3. Theta over 3 is the same thing as 1/3 times theta. So that tells me that the k value is 1/3. Okay, so if I think of that as 2 pi over 1 over 1/3, what does that give me? 6 pi. Okay, phase shift, that's the left or right, is C over K. C is this number here, K is the number in front of theta. C is pi over 2. K was 1/3. What does that give me? 3 pi over 2. And I am going to specify, is this going left or right? Look up here, is a minus. It's going right. Question on that? Okay. All right, so on this next one, I'm giving you information and we're going to write the equation. So we're going to write an equation of a sine function with period pi over 5 and amplitude of 6. Let's start with the easy part. If I tell you the equation has amplitude 6, what are you going to do in the equation? Amplitude is 6. How will that be incorporated into the equation? What? It'll go in front of sine. Okay, so I know that the equation will be y equals 6 sine. Does anyone want to argue that it could be something else? It could be negative. So generally what you will see is plus or minus. Because if I had a positive or a negative 6 out there, the amplitude is still 6. Okay, so let's take this idea of period as pi over 5. And I'm going to use that same formula that we had up here. Period is 2 pi over k. Okay, well, I know that this is the value of the period, so I'm going to sub that in. And I'm going to say pi over 5 is equal to 2 pi over k. Does that make sense? Period, I know what the period of the graph is, equals 2 pi k. Now I want to solve for k, and that'll tell me what number to put in front of theta. So I have a proportion, two fractions that are equal. I can cross multiply. Pi times k is pi k. 5 times 2 pi is 10 pi. I'm solving it for k, so I'm going to divide by pi. And I get k equals 10. So now I'll take that 10 and put it back in the equation where the k was. So I have 10 theta. Okay, I did not give you a phase shift or a vertical shift, so we're done. Question? Okay. All right. Do we need a 5-minute break? Yes? Okay, let's do a 5-minute break, and then we're going to graph some of these, and then we'll call it a day. Pause this. You need a restroom break now? Okay. All right, so let's graph some of these. All right, our equation is -3 cosine x. -3 cosine theta. It's the same thing. What is the amplitude going to be? 3. What is the period? 2 pi, because there is a 1 in front of x. So it will be 2 pi over 1, which is just 2 pi. Do I have a left-right phase shift? Nope. Do I have an up-down vertical shift? Nope. Is it reflected? Oh, sorry. Is it reflected? It's not listed, but is it? Yes. And what's the midline? So where's the line that I'm going to shift over and under, over and under? If it's not shifting up or down, the midline is on the x-axis. What's the equation for the x-axis? Y equals 0. Doesn't that seem backwards? But you think of any ordered pair on the x-axis, it has different x values, but all the y's are 0. Okay, so y equals 0. Okay, so how am I going to graph this? Go back to your cosine function. This is what we're going to do, but we're going to flip it, and we're going to make it go up to 3 and down to -3. Okay, so what I'm going to do is this. I'm going to find where it's crossing the midline, where the maxes are, where the mins are. Okay, so if I'm not shifting left or right, isn't it still going to cross the midline at the same place? Okay, so cosine crosses the midline at all the half pi's. -3 pi over 2, -pi over 2, pi over 2, 3 pi over 2. So let's mark all of those. If this is pi, then halfway is a half pi. So I marked my center line, my zeros, my x-intercepts. Okay, now normally I would say above 0, we're going to be at a maximum value. But this one's been flipped. So instead of being at a maximum, I'm going to be at a minimum. And what will the minimum be? -3. So I'm going to jump down to -3 right there. So remember, I reflected this over the x-axis. So I'm not starting at a max, I'm starting at a min. But then between the next two zeros, the opposite happens. So if I move between these two zeros, I have to reach that maximum value of 3. And you just keep alternating. Okay, I'm kind of out of room over here. I could make it right there. And then when I go this way, if I went to a minimum here, the next one will be at a maximum. And then over here would be at a minimum. And then we connect them. Connect the dots. Remember, make them a smooth curve. How many full waves did I just graph? 2 full waves. Now, can you graph that on your calculator? Absolutely. And it can kind of help you get started. So let's see what that would look like on the calculator. Y equals -3 cosine x. And did that match what we just did? Yes. Okay. Alrighty. Next one. What's my amplitude? 1. That lead coefficient is just 1. This number here that's 2, that's the what value? K or C? K is 2. And I will use K to find the period. Period is 2 pi over K. So that's 2 pi over 2, which is pi. Okay, is that going to stretch it out or squeeze it in horizontally? Squeeze it in. I should find 2 more curves than normal. Twice as many. Okay, do I have a phase shift? Is that -3 inside the parentheses? Nope. But it's after it, so that means I have a vertical shift of -3, or to clear up what I mean by negative, I'm just going to say down 3, so that there is no guessing. And the midline, okay, if everything shifts down 3, I'm not oscillating over that x-axis anymore. I'm oscillating over what? Y equals -3. Okay, so this is the very first thing I'm going to do. I'm going to mark this line. I'm going to dot it kind of like we did asymptotes, even though this is not an asymptote. I'm just dotting it to remind myself that this is the line I'm going to be going over and under, not the x-axis. Okay, so it is a sine curve. This gets a little tricky, guys. Here's my sine graph. Normally, I would fit 1 full wave in 2 pi radians. I have to squeeze 1 full wave in 2 pi radians. So that means I need a 0, a max, a 0, a min, another 0. Let's look on our graph. How am I going to make that happen? I need a 0 here, and I need to finish a full wave by the time I get to pi. I have to squeeze a whole wave in right there. Okay, well, if that's the whole thing, halfway is going to cross back over. Halfway between those, I'm going to be at the max, and halfway between those, I'm going to be at the min. Do you see how I squeeze that in? So one more time. I know that normally in 2 pi I have a 0, max, 0, min, 0. But I had to make all 5 of those points happen between 0 and pi. So I had to squish it in 0, max, 0, min, 0, just in pi radians. And then you can keep extending that pattern a little bit just so we have enough to connect. So basically every line I'm changing it up, aren't I? So now I'm going to go down, back to 0, up, back to 0, down, back to 0, etc. And I'm going to connect them. Like that. let's do this next one. What's the amplitude? 1. Despite the fact that there's a negative out front, amplitude is just 1. What's the period? 2 pi, because there is a 1 there. K is just 1. So 2 pi over 1 is 2 pi. Phase shift. Right pi. Because of that minus pi, everything's going right pi. Vertical shift, none. If there's no vertical shift, then where's our midline? Y equals 0 on the x-axis. This one is flipped, though, isn't it? It's reflected. Okay, I think we're going to make this one our last one, because I'm getting kind of tired of it. All right, here we go. Everything shifts right pi. Take your sine graph. If I picked up this curve and moved everything right pi, then this point will now be here, and everything else moves down. So what I'm going to do is I'm going to go to pi, and this is like my new origin. So I will be on my way up and back down here. I didn't flip it, did I? Cross that out. I'm going down first instead of up. Okay, so this little curve that I just made would normally be this curve, but I moved it right and flipped it. Isn't it going to look like this one now? If I follow that pattern, look what happens. I'm going to go up next, right? So I'm going to go up and back down. Doesn't that look like a normal sine curve? So if I shift sine right and flip it, it could look like the original, which is what's happened here. Down, back, up, back. And we connect. Ooh, I overshot that. Here we go. Question. Okay. I have some homework for you. Okay, on the homework, guys, I want you, on the back, there are some more of these. I want you to fill in all of this. Y'all look up here for a second. I want you to fill in all of these on the back, but pick any 2 to graph. Pick your choice of 2 to graph on the back. Okay?